Hi, my name is Andy Ebbs. I'm a solution consultant at OpenText, and today I'm going to be taking a quick look and demonstration of how to migrate servers from VMware to Nutanix. This is part of a series of different videos. I'm showing lots of different environments. Most of them will be fairly similar, the actual workflow we'll use, but to make things a bit clearer, I'm going to be using different environments such as Nutanix today and a VMware, where we've seen quite a few customers migrating from VMware to Nutanix, but also sometimes the other way as well. But that's maybe a different video if you want to have a look at my YouTube channel. So the solution we're going to be using is Carbonite Migrate, and we're going to be using the solution which is Windows Full Server Migration Workflow. I don't know if you can read the text on the screen, it's quite small maybe, but it gives a quick summary of what we're going to be doing today. But essentially I'm going to have a source machine running on a VMware platform, running Windows 2019, and I'm going to migrate that to a target environment running in Nutanix, which will also be running Windows 2019. And we have a way of migrating a live copy of the system state while everybody's continuing to use the server, so there's no downtime while we synchronize it over to the target. And then once everything's in sync, we will do a cutover, and you'll see the target machine become a clone of the production server. So to start off with, I'm going to just switch through to my consoles here. So I've got a VMware environment. It's only a small one, just a single host, but on here I've got a Windows 2019 source machine. So you can see it's got a name W19 ESX source. So this is running in this platform. I can, as you can see, access it, and I can create a file, and I'll maybe just call it Andy. There we go. So we've got a file on the desktop, just so you can see it's a live server. I've also got a Nutanix environment here, as well as all the Proxmox ones I've done from other demos and so on. It's again just a small Nutanix environment, so I can do demonstrations and so on. But if I quickly just log into that, just log me out, you'll see the Prism console as that pops up once it logs my credentials properly. Now please ignore these warning messages. I'm fairly new to Nutanix, and I've tried clearing a couple of them up, but I think it's just my fairly small environment that's been pushed to the limits, and occasionally it runs out of resources. Hopefully that won't happen today. But in this environment I have a couple of virtual machines that are currently running. We should be able to get to those from here. So I have, that's the appliance, but then I've got an Ubuntu machine. I've also got this Windows 2019 machine I've called W19 Nutanix Target. I've not really provisioned it particularly high. It's got a couple of gig of RAM, a couple of processors. I could probably give it a bit more resource if I wanted to, but I don't really want to have to restart it all now, so I'm just going to use it as is. We'll connect into the console. So this is a console showing that machine, and as you can see, it's got the name W19 Nutanix Target as its host name. Now that we've got access to those two machines, I'm going to go to the Carbonite replication console. So this is the Carbonite replication console I'm going to be managing all the jobs from. In this console I have a variety of different machines that I've used for other demos. So I've got some Proxmox machines in here. Here's the W19 ESX source machine. I've also got the Hyper-V environment, and I've got some Ubuntu machines and things like that as well. So we're going to be going from this ESX source machine to this Nutanix target. The machines with the crosses and so on next to them just mean they're not actually turned on at the moment, can't connect to them, or it's trying to connect them to gather information. But you can add lots of servers in here just by clicking on add server, server name or IP address, username, password and so on. So it's pretty straightforward to add machines in, and once they're in the console we can also administer them, so I can do things like I'm going to use to migrate in a second, but there are options here for also viewing logs and gathering support diagnostics and things like that as well. There is also a push installer, so you can add the machines to the console and then you can use our tools to push them out as well. To keep things a bit simpler, I've got a group set up for these two machines. So I've got this Nutanix group here, so you can see there's the ESX source and there's my target. So if I choose the source machine, right click on it and choose migrate, that will give me a menu of 3 different workflows. So we have different workflows that allow us to do slightly different things. Sometimes you just want to move some files and folders, so we don't have to do the whole system state. If I was going to a VMware or a Hyper-V environment, we have another workflow which will do a bit of automation by talking to vCenter or to ESX. Now we don't currently have that for Nutanix, maybe in future. If people find that's going to be useful, then just let me know and I'll put that on our wish list. But at the moment we still have a workflow that will work with it, which is called the full server migration. So I'm going to choose that one. This basically defines a set of rules that are going to be used for replication. So you can see all these files and folders are going to be replicated. The ones in green mean there's they're part of the replication set, so all the files and folders within there will be included. And the ones in grey or not coloured in, they're basically going to be excluded. And that's useful because we don't need to replicate the recycle bin or the page file or the system volume information and so on. They can be excluded from the replication because they're changing a lot, but there's no valuable information there that you'd need to migrate. So by excluding them, we're not wasting time trying to replicate what might be quite busy files which are changing all the time, creating lots of data and using lots of bandwidth to send them over to your DR environment or your target environment. So we can exclude those. So the next thing I'm going to do is click Next, and I'm going to confirm the target machine. So the target machine I've got here, I've got a target in Nutanix, so I've got Proxmox there as well, but I'm going to Nutanix. So this is a Windows 19 machine that I've already created. It just needs to have the same version of Windows on it. So if the source is Windows 2019, then the target needs a plain Windows 2019 target environment. And what we're going to do is install an agent on the source machine, on the target, and then we're going to synchronize a copy of the system files over to the target, and then we're going to transform it into a copy of the clone once everything's in sync. So if I click Next now, it will give me a few options on some of the other settings that we might want to apply as part of the migration. Now these are options, you can ignore some of them, but there's a few useful ones I like to turn on. So we've got the name of the job at the top there, so we're going from our ESX source to our Nutanix target. We want control of when it actually fails over. We want to shut down the source machine so we don't end up with two live servers with the same name and identity on the network. There's options to include scripts that can be triggered as part of the failover, before and after failover, to maybe stop other services on other servers while you're doing the migration, or send out messages and things like that. We're going to fail over, and I want to keep the target machine's network identity just because it gets easier in my home network here. If you want to fail over the IP, that would be the default action, so we would fail over the source machine's IP to the target as part of the migration. Most migrations are tend to involve the cloud, or you're going to a new data center, so being able to keep the target machine's network settings is usually quite useful. And if you're doing so, then we can also update the DNS settings. Now these machines aren't in DNS, so the options are grayed out here, but this is where you can specify your DNS server, and we would then be able to change which source IP address gets applied to the target and so on, so that users will be able to connect to it and continue working automatically after the failover is completed. We have a option for the network cards. So if you've got multiple network cards, you can choose which one attaches to which network card on the target, or discard them if you've got more network cards on the source and you haven't got enough on the target, and so on. There are options for the synchronization. You shouldn't have to change those. You can select a particular route for replication if you've got multiple network cards or multiple paths through your network. Some might be optimized for the migration. Some might be for normal internet traffic that you want to preserve for voice over IP and things like that, or a WAN accelerator. So you have the option to change the network route. We're going to be basically putting a copy of the system state files into a temporary area on the target machine that we call a staging folder. Now this is automatically handled by the wizard, so I don't really have to get too concerned here, but you can see the files that are going to get in that staging folder. It's basically all the system files. Sometimes there might be an application that's really unusual and it doesn't store files in program files or in Windows or something like that, so you have the option to add them in. I've never had to do it though, so I won't go into more detail on that. Then we have the target services. So these are basically services that are running on the target machine that might interfere with what we're trying to write to disk. So we have to have some services running, but we wouldn't want, for instance, SQL running on that target machine because it might block us replicating SQL files because it would be locking those files out. So we would by default stop anything that we don't consider to be essential. Now there's a lot of essential Windows files, and that's really why we're putting everything to the staging area, but there is some applications, things like antivirus or intrusion detection software, that you might need to have running on your target machine for policy reasons. And if that's the case, you just need to make sure that if you have an antivirus running on the target, you add it to here to keep the service running so that we don't shut it down. But then you can add in our software into the whitelist, otherwise it's going to maybe slow us down or block the activity as we're writing files to the target. There's compression. We've got 3 levels of compression, or 4 if you include turned off. I tend to set it to medium. Compression will really reduce the amount of data that gets sent over the network. It's intelligent. It only tries to compress files that it knows aren't compressed. So if we see a zip file or a JPEG or an MP3, we don't waste time trying to compress that data. If we were working at the snapshot level or the volume level, which a lot of our sort of competitors would use, they have like an all or nothing compression. So you have to compress everything or nothing, but we can be looking at individual files and folders as we're replicating them, and only compress the ones that we know we're going to benefit. There is bandwidth options, so you can limit how much bandwidth's available as a fixed amount, or you can add a schedule so that on certain days of the week, or maybe on weekdays between 6 in the morning and 6 at night, we limit to a 10 meg link, and outside of those hours it's unlimited. So again, if you've got voice over IP and terminal server connections and things like that you want to preserve bandwidth for, you could maybe restrict the amount of bandwidth that DoubleTake uses, or I should use the term DoubleTake there, it's the old name for Carbonite Migrate. But it allows us to preserve that bandwidth for other activities on the network during the office hours, and then outside of hours we catch up. It just means your migration might take a bit longer. I'm going to click next and we validate. So this is basically checking the settings that I've given it are usable. It's giving me a warning there, just basically telling me that my source machine has 4 gig of RAM and my target has 2 gig. So I'm not worried about that. It means the machine, when we fail it over, maybe runs a little slower than it did on production, but it's just a plain Windows operating system I'm using here, so it's not really going to cause any issues for my demo. But you can see we are checking to make sure that all the other configurations that we think might catch you out are sort of checked, and we'll warn you about it beforehand, or tell you if something's going to be a problem. So we're checking the versions of Windows and checking you've got the right networking and things like that. Then I'm going to click finish, and it will create a job for me. So this process will just take a few seconds, but it will take me to the job screen, and we can see here is a new job that's been created. It will tend to flash red and orange as it just configures itself, but it will stabilize to an orange light here, and once we're in sync it will change to a nice green tick, but that's going to take a little while because we're going to have to synchronize the data. So what's happening at the moment is it's started synchronizing, but it's also calculating exactly what it's going to have to send over the network. Now that might take it a few minutes while it works it out, but it's already started sending data. So you can see it's already sent about a gig of data and about 700 meg after compression. I'd normally expect it to halve the amount of data, but it depends on the types of files it's replicating or synchronizing at that point. So while it's just doing that, I'll just quickly show you the target machine again, because one of the interesting things I can show you is if we look at the target machine, so on the Nutanix machine, if you look at the file system, now I've just opened File Explorer, and in here we can obviously see the different drives and so on. So I'm just going to go to the C drive, and I wanted to show you the staging folder. So the staging folder is basically there so that we can put files temporarily into this folder while the data is being mirrored or synchronized to the target machine. Now we have to do that because, as you can see, my target machine is a running Windows operating system, and if you start overwriting system files while it's trying to run an operating system, you're going to get blue screens and all sorts of pain. So we just put the files temporarily into here. So if we go into staging, we should see a files directory, and in the file you can see a copy of the registry being created there as well, but we can also see a files directory, and in there we've got Windows and users, and Windows likes to hide some of these settings as well, so I might need to just say show hidden items as well, and you'll get things like registry dump and app data will appear and things like that in a minute as well. I can go into users, I can drill into administrator, and at the moment I think desktop is probably empty if I go in here, because we haven't actually got to that file in the mirror, because it is still synchronizing even though I'm obviously playing around with that target machine. It's done 10%, So it's still got 21 gig of data to send over the network. It's maybe going to take it a few minutes. But what I can show you is if we look again at this file, this desktop here, nothing's changed yet. But if we were to go to the VMware environment, and I'll just change that file to give it a different name. So I'll just change it to, it'll take it a second or two, but when we go back to the Nutanix environment, that file will appear here with the new change that I just made. Now, the reason it'll take it just a few seconds is it's also sending lots of other data across the network at the same time, so there's other traffic in the queue. But we send these changes with priority on new data. So it's, although we're mirroring or synchronizing all the files from the source to the target at the moment, we're also replicating all the real-time byte level changes as they happen on the production server. So as soon as I change that file from Andy to mirroring, our filter drivers, which are running as part of our agent on the source machine, will see that byte level change to that file. Even if it's just a few file attributes there, it will see those changes and it will synchronize them over to the target machine, or replicate them to the target machine as quickly as it can. We're still mirroring other files in the background as well, so it's still going to take it a few minutes to complete. But essentially what this means is we could have a live SQL database with lots of real-time byte level changes happening to it, and we'll see those changes happening to the database and the log files, and we'll send them over, and everyone's got a transaction number, and we'll make sure that they're all written to disk in exactly the same order. So I'm going to switch back to the Carbonite replication console, and as you can see it's now at 17%, so it's still going to take another 10-15 minutes, maybe half an hour to synchronize. My home network's not that quick, but I'm going to pause the video and I will continue in a couple of minutes time. Okay, so after a little while of waiting for the data to get mirrored, we now have a nice green tick. You can see that it sent quite a bit of data over the 21 gig there, after compression 12 gig. It did take it a little while, but I do something else for half an hour, something like that. It'll depend how long that takes, depending on the type of data, the size of the machine, the rate of change, the latency on the link, speed of the machines that you're migrating. So there's quite a few different factors there. If you've got any questions about that, you can always give me a shout. But we're now in a position where the data is now in sync between the source and the target machine. We should be able to see those two machines are active still. So we've still got this machine here, so I can maybe make a change to, if I can find my mouse, there we go. If we change this to mirrored now, because we're in sync, and if I switch over to my Proxmox machine, not Proxmox machine, my Nutanix machine, sorry, we should find that it's disconnected because I've been logged out. Let me just quickly log back in again. So when I go in there, you can see it now says mirrored. So that would happen pretty instantaneously. I could probably just repeat that just so you can see that the replication is now working at full speed. So we'll just go in here and we'll change it to about to, or maybe failover time. So we're about to do the failover, so I've committed that change, and as I say, that could be any change to a database or anything, but you can see as soon as I switch back, that change is being replicated over. And the same would be true if any other changes are happening on the server now. So if it's live SQL databases, it could be Oracle, it could be SharePoint, it could be a bespoke application. We don't really care what the application is you're working with on your production server. We're able to replicate them all because we're replicating the whole system state, so the configuration of all the files, regardless of what database type or what type of application it is. So we've got that data in sync, so we can now go back to the Carbonite replication console and we can choose to fail over. So I'm going to click fail over. So fail over or cut over. You can use the button at the top there. I'm going to cut over the live data. These other options here, they're grayed out because this particular workflow doesn't support them. And also this solution can be used for high availability, and in high availability type scenarios you might use more regular testing of the environment and things like that. So we built some testing into that. It's not really applicable to the migration one because it does need an additional machine to do that testing. There are other ways of testing. Again, if you want to see that, I'll probably set up another video on that, but if anybody has any questions, then give me a shout. And because over the snapshot, we're not replicating snapshots, and just to emphasize that, we replicate the file system in real time and at byte level. But in a high availability scenario, because we're replicating live system files, potentially you could be replicating corruption or malware or something like that on the production server. So you don't want to be having a high availability solution that you fail over to that's also got those replicated changes that are just going to cause that machine to fail as well. So we can take scheduled snapshots of the data that we've replicated and fall back to them afterwards. So that cutover to snapshot is only available in the high availability version of this software, and because I'm using a Migrate license, I don't get that option. But you'd never fail over to an old version of your data in a migration, so that's why we don't include it. So I'm going to cut over. Now this will take it probably 10 to 15 minutes. It depends on the time it takes to shut down my source machine. We should sort of see that happening now. If we go back to my VMware environment, you can see my VMware source machine is now being shut down automatically. And then we'll start on the conversion process of turning that target machine that's got a staging directory with all the system files from the source machine into a clone of the original production server. So yeah, the source machine is now offline, so I'll just close that down. You see the machine is powered off at the moment. If we go back to the Nutanix virtual machine, that's still online, and it's doing, you can't really make changes to it at this point. You need to really leave it alone. But after 10-15 minutes, this machine will reboot, and once it reboots, it will have a different host name. So at the moment, it's still got the Nutanix target name there, but we're waiting for that to reboot and it will become a W19 ESX source, will become its new name because that's the host name of the original source machine. We get a countdown as to what's happening. At the moment we're about 6%. It's like one of any of those percentage bar type things. It will suddenly jump up, will suddenly go to 20%, then 50%, then it'll hang around for a little while, and then it'll go to 100%, and we'll be able to fail over. So the failover will be complete at that point. So what's happening in the background is we're moving all the files and folders from that staging area I showed you earlier over the top of the plain operating system. We're moving them, not copying them, so it's quite quick. And then we're also merging the registry from the source machine with the registry of the target. When we're doing that merging, we preserve all the hardware configuration of the target machine, and we just basically don't apply any of the hardware keys that we've copied over from the source. So we're only doing the software layer. So if you had an ESX virtual machine with VMware virtual machine drivers, they're going to get discarded, and we're going to keep the KVM network adapter and the KVM graphics adapter and all those sort of KVM stuff intact in the registry on the target machine. Obviously there's quite a bit going on there, including moving these files around and making those registry changes, so it's going to take a little while. So again, I'm going to pause the video and just let that get up to 100%, and we'll be ready to do a see for the successful failover. Okay, so I'm back again, and the job has completed now. It's taken a few minutes, well, it probably took about 15 minutes to do the failover, but I've been off and had my dinner. I've come back and it now says failed over, so the migration is completed. We can check the environment. So again, I just need to quickly log into Prism again. Now I've not actually tried this many times. I did it to test it when I first set this up, but I'm just wondering whether I can connect into the existing window. I think I need to maybe restart it because I think the machine's been restarted, so we'll just quickly do that. So I'm going to go to the virtual machines. I'm going to choose the machine which has still got the virtual machine name of Windows 19 Nutanix target, and then we'll log into a guest tools, oops, launch console I mean, and there's Windows. So if we go to Control Alt Delete and log in with Carbonite, and here we have it. So this is the desktop. You can see it's got the failover time, which is the last change I made to the machine before we triggered failover. And as server manager comes up, we should be able to check what the host name is, and it should have failed it over. So although we're connected to W19 Nutanix target, because that's the name of the virtual machine, the host name of this server will have been failed over from the source, so it is now W19 ESX source. Yeah, so that's it. So thank you for watching. If you're interested in other platforms, you know, I've done quite a few other videos now for things like Azure and RNS Cloud and Azure, Amazon, and Google Cloud. Please take a look, and if you've got any questions, please get in touch. And just in case you need to do that, my email address. Okay, thank you very much for watching.